Please welcome Dan to the stage.
I submitted this talk because honestly, this is a conversation I'm having with customers on a daily basis. Organizations are looking at how they can get greater visibility in the industrial control space, and there's a lot of architectures and technology out there that exist, and customers, it's causing confusion. So I'm going to try this. Sorry if I'm the 100th person to do this already, but show of hands. How many of you would you consider yourselves to be, IT, or you're reporting through an IT organization? Okay. On the other side of that, how many would consider yourselves operations or OT? Okay, appreciate that. So, realistically, I work for Cisco. You don't get to pound your chest and say you're the #1 IT company and then be upset that people think of you as an IT organization, right? But we are constantly being brought into customers, typically being sponsored by the IT organizations, to have conversations about deploying security in the industrial space. Executives, board levels are making the determination that IT needs to become more involved, and we're seeing that to continue to evolve. And so again, the real purpose here is just to dive into some of the architectures and some of the implications of some of the solutions that are out there. So what is this talk? This is my attempt to try and outline some of the options for organizations. Going to try and deep dive and talk about some of the ramifications of some of those decisions. As I mentioned, we're constantly having conversations with customers, and some of the common themes that come up are on the screen in front of you. Secure connectivity. What devices are on my network, and how do I restrict their access appropriately? Understanding what's vulnerable and how can I protect those vulnerable assets? People are involved in these environments, right? How do I make sure I'm keeping them safe, both from a network standpoint as well as from a device standpoint? And then remote access, right? There's no shock, there's a talent shortage. How do I make sure that my best assets are utilized and able to solve problems at multiple sites, not just the one where they're currently located? I'm going to try and go through some of the pros and cons of the different approaches and just talk about, again, those architectural implications of deploying these. I'm focused today on permanent solutions, right? Obviously, in incident recovery, it's very practical to have someone standing on the shop floor with a PC running Wireshark, right? I'm talking about solutions that are going to be running long term and as part of your infrastructure full time. What isn't this? This isn't meant to be a sales pitch, right? I'm going to do my best to be product agnostic. I'm not going to mention any products by name specifically. Just want to talk about the overall solutions and the implications that go along with that. This isn't product specific, and I mean that in multiple ways. This isn't just focused on Cisco, and this isn't just focused on many of the vendors that are out there, even though some of the things I'm going to bring up may ring true for a lot of the solutions you're going to see. This isn't exhaustive, right? There's many solutions that are out there. I'm just going to cover a couple of the big ones that we hear a lot about, and I have to make some assumptions, right? To be able to present some of the data points we're going to dive into, I have to have the ability to level set, right? So I'm making some assumptions, and I'll call that out as I do that. So what are the main types or mechanisms for collecting traffic across the network? First one is record-based. So Cisco developed a technology known as NetFlow. It's gone through several iterations. Today we're at version 9. And version 9 was really the basis for the open standard known as IPFix, or the IP Flow Information Exchange. And this is just a mechanism for network devices and for appliances to generate records about what traffic they have visibility to and summarize that information. Also going to talk about raw packet, the ability to send the actual traffic that's flowing across the network to some collector or some appliance to do analysis on that information. And I'm going to talk about the ability to do that out of band as well as the ability to do that inline. So as I mentioned, NetFlow is the ability for a device to generate records about the traffic that it has visibility to. Just as a disclaimer, I'm going to say NetFlow the entire time. Everything I'm saying about NetFlow also rings true for IPFix. But NetFlow, many of you have probably heard the analogy of the old cell phone bill records that we used to get that showed us the call information, right? I could see who talked to who. I could see how long or the duration of the phone call, but I couldn't see what is said. Right? I don't know what the exact conversation was. I just know what devices are talking to each other. That's NetFlow. The ability to do this everywhere. Right? When Cisco originally developed it, it was primarily a router function. It's now in our entire portfolio and in many devices that are out on the market support the functionality. And so the ability to do it in switching and routing and firewalls and even in appliances that collect raw traffic and then generate NetFlow records as a result. And we'll talk about some of that as well. The original intent for NetFlow was to measure network performance and network utilization, right? To understand what's my WAN bandwidth utilization and what optimizations or enhancements do I need to do to support that. But there are a lot of uses for security purposes, and we'll talk through some of that as well. NetFlow is going to give me the ability to see both north and south, or if you imagine your laptop accessing an application in the data center or in the cloud, or somebody else's data center, that's north-south, or the ability to see devices that are communicating directly to each other, east-west. In industrial environments, most of our traffic is east-west. Right? And version 9, or IPFix, has the ability to do a template-based approach. And what that means is I can actually select which fields of information I want to be generated and reported back through my system. The other thing to call out, and I should have said this earlier, the solutions I'm going to talk through, the value of this information is really dependent on what application is collecting it and presenting it to you. Right? So I'm focused on how do you get those data sources, but NetFlow, for example, if it's a security-focused product that's looking at the information from a security aspect, it can give you security information. Again, though, we're only going to see who's talking to who and for how long. Right? We're not going to know exactly what was being said. Flows are typically going to be aggregated. Usually around 30 flows can, timing-wise, ends up being in a typical export from a device. There are differences, not only across vendors, but even within vendors, on how different platforms support NetFlow and the way the exports are actually generated. In typical Cisco switches, there's an inactive timeout. So if I send a piece of information and close the connection, about 30 seconds later is roughly is when that export is going to occur. And then there's an active timeout. And this is if I'm continuously having a conversation. About 60 seconds into that conversation, and every 60 seconds after that, I'm going to send that information. This is configurable in most platforms, but 30 and 60 is the default, and those are the numbers I'm going to use for some of the future numbers here. We're not sending the entire packet. Right? We're just sending the header information or whatever fields we've deemed in our template that we want to send. Now, because there's a template approach, the size can vary. Right? I could have the ability to shove many different fields in there and grow the size of the export. But I'll say the default template that most products leverage to gather that information is about 60 bytes per flow. And again, that is dependent on that template. So in the industrial space, things like HMIs or I/O or any type of connected messaging, these are going to be long-lived flows. These are going to be kind of counted against that 60-second timer, so to speak. And then we have the unconnected messages, right? Things that are infrequent, things that don't have follow a constant pattern. These are going to be short-lived connections, and those are going to hit that 30-second timeout. So just to throw some numbers at you, in an extreme case, right? 16-port switch, which based on our information, is a pretty common size switch. If we look at a traditional Rockwell controller, some of the ones on the market today can support up to 300 connections. So in extreme environment, if I plug 16 Rockwell controllers into a switch, and I used up every single one of those connections, I'd be looking at about 4 megabits. And kind of a weird way to represent that, but the reasoning is if those are all connected connections, I'd be looking at about 4 megabits per minute. Right? Not a ton of data. In an unconnected standpoint, I'd be looking at about 8, right? Because I'm hitting that 30-second timeout. From an IT standpoint, when we're typically discussing NetFlow and some of the implications to the architecture, we're usually going to talk about, for a rule of thumb, we're going to say 2% of the monitored ports. Keeping in mind, though, if I did 16 times the 100, that would get me all the way up to 32. But keeping in mind that in IT, we're usually talking about the uplinks, right? We're usually talking about greater traffic flows. That would be an extreme number talking about east-west traffic. And in NetFlow, most platforms will support the ability to automatically QoS mark or quality of service mark that packet. Right? So if I hit congestion in the network, I can make sure that this traffic is dropped before my important control traffic. So when we're looking at the implications of how we're going to deploy NetFlow, there's the biggest piece is I can only provide or gather NetFlow information from my, and I use the air quotes here, lowest device that supports NetFlow. And what I mean by that is if you look at it from a common architecture, right? Core aggregation access, lowest meaning access would be the lowest. If I can support it, if I can only support it in my aggregation, for example, in my little simplistic visibility here, we can't see A talking to B because it never makes its way up to the aggregation. right? So the what platform or where I can support my NetFlow is going to impact what visibility I have. Obviously, if my access switches do actually support it, I'm then going to see all those flows. Another note, so typically, when I'm saying NetFlow, I mean full flexible NetFlow or full IP fix. There are some platforms that do what's known as sampled. So instead of sending you a record for every single packet that goes across the network, we take a ratio. Usually it's in the thousands, like 1 to 1,000 type of scenario where we create that. That's not going to be granular enough for ICS traffic, typically. It's not going to paint the entire picture for you. And this can be leveraged, so if you don't have switches that support NetFlow natively, this can be leveraged with an appliance or a firewall that can actually take in the raw traffic and then create NetFlow records, either through an out-of-band, and we'll talk about this here in the next slide, or through an in-band solution. If it is a firewall that you put in band, it's a firewall, right? You'll have all the firewall functionality, so you can do things like deep packet inspection beyond just the NetFlow. And you can even go so far as to leverage enforcement if you were to do that. We'll dive into the raw packet and some of the implications around that. So when I'm looking at raw packet, when I'm receiving all the traffic that's going across my network, I'm getting all the data as well, right? So I can see exactly not only who's talking to who, but what's being said. If I have a process where there's 5 steps that must be followed in an exact sequence for a shutdown, I will see that all 5 steps occurred and know that the sequence was appropriately followed. That requires me to have some ability to get that traffic, though. And so there's a couple ways to do that. Cisco, we tend to use the term SPAN, which is Switch Port Analyzer, more generically referred to as port mirroring. It's the ability to take the traffic that is coming in and out of a port and replicate it to another port. So locally, that's referred to as port mirroring or SPAN. There's also remote options, so the ability to actually send it across the network. Cisco refer to that as remote span or RSPAN, typically referred to as remote port mirroring, more generically speaking. And then Cisco also has the ability to do a functionality known as ER-SPAN. It's actually the ability to take the span traffic and embed it or encapsulate it and send it across the network. The benefit here is I can route that traffic now because it's been encapsulated, but it does require I support ER-SPAN on both ends of that connection, so to speak. And then there's also the ability to do inline functions to put devices in the traffic directly using things like taps. So if I'm doing that local monitoring, right, I'm doing it all on the same switch, that obviously means I'm going to need to be deploying a great deal more collectors or appliances or whatever the device that needs to receive that traffic may be. So I'm going to have to manage and monitor all of those devices. I'm going to start deploying a great deal more assets in the environment. Some organizations are actually going so far as building out a completely out-of-band network specifically for getting that raw traffic. Obviously, that means that's more infrastructure to support. That's more pieces that need to be monitored and configured. Or some organizations are sending it into I'll say a more capable switch, something that's able to do that R-SPAN or that ER-SPAN and send that traffic across the network. SPAN or port mirroring is fairly common. Most industrial devices or industrial switches today actually support the functionality, but it is something that requires a managed switch to be able to do, and obviously requires the ability for the switch to support it. So just for awareness, not all switches support it, but it is a lot more standard across most portfolios. And compared to NetFlow, right? NetFlow is very product specific and typically a higher level function in most product families. And obviously, if I'm doing this all locally, I'm only impacting the local switch itself. So can that switch's backplane, so to speak, handle the increase in traffic? If we move to a more remote methodology, obviously the benefit here is I don't have to deploy as many collectors. I have the ability to send that traffic elsewhere or aggregate that traffic in another location. I can use my existing infrastructure, so I don't need to stand up a completely dedicated infrastructure. Still could, but don't need to. This is less common in many industrial switches and devices. So again, there will be some determination on if your hardware can support it today. But because we are going to be sending this traffic across the network, we need to start considering the overall implications to the network that traffic could have. So again, the difficulty here is because I'm now actually talking about the data, right? I'm sending the entire packet and duplicating that entire packet. So this is going to be extremely dependent on your application, right? Some extreme examples, if we go back to that 16-port switch with a Rockwell controller supporting up to those 300 connections. The EN2T from Rockwell, for example, supports up to 25,000 packet per second. So aggregate that all together, we could get up to about 20 megabits per second per device, or 320 megabits on that 16-port switch. On the other end of that, though, so if you had a chance to see me out in the front lobby yesterday, I had that kit on the table, a couple of PLCs messaging to each other, some I/O and some HMI connections. That thing's pushing about 0.062 megabits per second. Even at 16 ports, we're looking at less than a meg, right? So there's a wide variety of what the impacts of this network traffic can be on your network. But just to give you guys some ballpark numbers, you can filter. So most devices that support spanning or port mirroring are going to support the ability to choose which traffic you actually mirror, not just by the port, but also using a filter. Of course, our reason for doing that in this discussion is to get full visibility into everything that's happening. So if I'm filtering that, I'm obviously losing some of that visibility. But that could be a mechanism to try and reduce some of the overall burden to the network. And you can apply QoS when you're doing that remote span. But you can't be selective per source device, right? You're essentially going to tag the quality of service for the entire remote VLAN. So anything that gets put in there is going to have the same priority. So if you have an asset that you're considering more critical, the ability to make sure you get its traffic before other devices is going to be a difficult task because QoS isn't going to help you in that scenario. And then from an inline standpoint, so this is obviously we're putting some device in the path to get this traffic. Again, placement's going to be key. There's going to be more scalability and management overhead, just like the multiple collector scenario. If it is a device that supports enforcement, obviously if it's inline, that means you can turn on enforcement. But there are throughput and latency needs that need to be considered when you're doing that. And there's network taps, right? A device that you put in line, connect the cables to, and it dumps the traffic directly to you. But you still need some way to get the traffic from that tap back to your collector or whatever that aggregation point needs to be. So again, with the placement, if I have a firewall in between my aggregation and my access, I'm going to see A talking to C, but not to B again. If I move that closer and put it directly in front of the PLC, I'm not going to see all those traffic flows that exist. So threw a bunch of numbers at you, hopefully beneficial in giving you a feel for some of the implications and impacts of deploying some of these solutions. Just throwing out my 2 cents. So there's value in both approaches. And frankly, oftentimes when talking with customers, it's where do we get started? Right? We have no visibility today. We want to understand what's out there, what type of traffic flows are occurring. NetFlow, as discussed, if your access or your aggregation supports it, is a fairly simple mechanism to just turn on and start collecting. Right? We don't typically need to change out hardware or to impact what's already been put in place. I can get some visibility today to at least understand what's talking to what, without obviously again being able to see the full conversation. But raw traffic, being able to see that full data set that's being passed across the network does give you that understanding of exactly what's being said. The other piece, and tangential to this presentation, is the considerations of who's going to be actually looking at this data. Right? Last year on the same stage, there was a great conversation or debate on having a dedicated ICS-based SOC versus an IT, using your IT SOC. The thing I would throw out there is that IT secure operations centers exist in most corporations and are looking at this type of data day to day. So looking at NetFlow information and understanding what's talking to what and if that changed is part of their daily practice, so to speak. Looking at control traffic and understanding exactly the shutdown process or what data should be in those packets, that's not a skill set that an IT SOC is typically going to have in place. Right? So when we start getting this data, we've got to do something with it. And so there's considerations on who's actually going to be looking at this data. We also need to design with these implications in mind. Right? The impact of the additional traffic on the network, the need for hardware to support certain features is going to impact our overall design. And so we just need to make sure that as we're moving forward and we're deploying these solutions, we're keeping that in mind. And I put hardware standardization here, but realistically, I'm focused on switch standardization in this case. But making sure you've got an infrastructure that can support these products and these solutions that you're going to be deploying to give you visibility is key and critical in being able to deploy this across your entire infrastructure. So with that, I appreciate your time. Thank you.